A densely planted aquarium is not just a beautiful display. It is a fragile, high-stakes battleground for essential biological resources. This pie chart illustrates the physical baseline of these plants. 40 to 50% of their dry mass is constructed entirely from a single element, carbon. In modern aquascaping, pushing a system to the high-tech threshold requires running light intensities at or above 0.5 watts per liter. At this high light intensity, a severe biological bottleneck occurs because natural surface agitation only infuses the water with 3 to 5 ppm of atmospheric carbon dioxide. Parts per million, or ppm, is a metric that describes the concentration of a dissolved substance within a larger volume of water. Without supplemental carbon to match the intense lighting, plant photosynthesis stalls, and opportunistic algae immediately seize control of the tank to consume the remaining nutrients. The limit of aquatic plant growth in high-tech systems is not light or fertilizer. It is a strict mathematical deficit of dissolved carbon. This gauge shows the scientifically sound solution, pressurized gaseous CO2 injection, which safely pushes water concentrations out of the natural baseline and up to the optimal 10 to 30 ppm zone. However, the high setup costs, the complex metal regulators, and intimidating compressed gas cylinders create a steep barrier to entry for hobbyists. To capture this audience, the aquascaping industry introduced bottled commercial alternatives, heavily marketed as liquid carbon or CO2 boosters. Commercial liquid carbon products contain zero bioavailable carbon. Their active ingredient is a chemical called glutaraldehyde. The industry has successfully marketed an industrial chemical as a biological nutrient, establishing a massive ecological misunderstanding. We have to examine what actually happens at the molecular level when this liquid is bilged into the water column. This diagram shows the molecular structure of glutaraldehyde, C5H8O2. In a fluid environment, the molecule remains structurally intact. It does not degrade into a usable form of carbon that plants can absorb for the Calvin cycle. The Calvin cycle is the set of chemical reactions in chloroplasts that convert carbon dioxide into sugar during photosynthesis. Despite dosing the liquid daily, the ambient carbon concentration in the tank remains stuck at the inadequate 3 to 5 ppm baseline. From a purely chemical standpoint, dosing liquid carbon leaves the plant's structural carbon starvation entirely unresolved. The true target of this chemical is the algae. Glutaraldehyde is officially classified as a potent biocide and sterilizing agent, heavily utilized in medical and industrial applications. In aquatic systems, its primary victim is Black Beard Algae, or BBA. BBA is a notoriously resilient, brush-like red algae that tightly anchors itself to hardscape and slow-growing leaves. To observe the mechanism of action, we need to look directly at the microscopic surface of an algal spore. Glutaraldehyde infiltrates the algal cell wall, targeting isolated protein chains. It immediately binds these chains together, physically linking them like ladder rungs. This reaction, protein cross-linking, pulls the internal network tight, causing the entire wall structure to lock rigidly into place. The cell wall loses its permeability, rigidifies, and the spore dies. Glutaraldehyde does not feed the aquarium. It chemically sterilizes it by assassinating the primary photosynthetic competitor at the molecular level. If the liquid is purely a biocide, why do aquarists consistently observe explosive plant growth after dosing it? This pipeline diagram illustrates the fierce ecological competition in an untreated tank. Plants and algae constantly battle, splitting the ambient light and water column nutrients between them. Post-dosing, with the algae eradicated by the biocide, the competition for resources drops to zero. The plants now secure a total monopoly on all existing light, macronutrients, and micronutrients in the water. The resulting lush plant growth is an ecological illusion. It is a biological surge driven entirely by the removal of competition, not by the addition of bioavailable carbon. With its true mechanism understood, we can reevaluate glutaraldehyde's place in the modern Aquarius's toolkit. This 2x2 matrix maps aquarium management strategies based on their actual biological outcomes, plotting algae eradication against biomass generation. Glutaraldehyde plots firmly in the bottom right quadrant, high eradication, low fertilization. Pressurized CO2 plots in the exact opposite top left quadrant, low eradication, high fertilization. There is a professional use case for liquid carbon. It is an exceptional tool for precision spot treatment to manage localized algae outbreaks and clear physical space. But the biological rule for high-tech systems running above 0.5 watts per liter remains uncompromising. To generate high-density plant biomass, the 10 to 30 ppm requirement can only be met by pressurized gaseous CO2. In the closed ecology of a planted tank, chemical biocides can temporarily mask biological imbalances, but they can never overwrite the mathematical mass balance required to build life.